Good morning, girls. Today we are going to demonstrate the experiment of simple pendulum measurement of errors. You are already familiar with simple pendulum in your intermediate classes. In intermediate, you have done simple pendulum experiment, and what did you find? You found out the acceleration due to gravity. Okay? The same experiment when you are doing it here. This acceleration due to gravity, when you conduct an experiment at different places and at different instances of time, the value you are going to get is going to be different. So, the difference in the values can be attributed to many experimental conditions. The way you conduct your experiment, the way you fix this attachment, and the way you fix the knob, this is a fixed end, and how you tie it, and how much of a resistance is being offered. All these factors do contribute to give you different values. So the experimental setup remains the same as we've done in intermediate. But here what we're calculating is at different times when you do this experiment, how much error or how much deviation you are getting from the actual value. Okay? And this is attributed to what is known as the measurement of errors. That means an experiment, when it is repeated at different times, you are not going to get the same value. The deviation what you are getting is termed as an error. And when you plot this deviation against the actual values on the x-axis, and also how many times that value that you are getting, the value of difference, then it forms what is known as a Gaussian curve. The Gaussian graph looks something like this. So you plot error on the x-axis, the frequency of error on the y-axis. This is known as the center. This refers to the deviation. Supposing you get error frequency. If you get plus 1, how many times are you getting? 5 times. Minus 1, 4 times. Plus 2, 3 times. Like this, you must tabulate and plot it on the graph. And this should take the shape of a bell. This is known as Gaussian distribution. So your tabular column, to draw this sheet, what you do is, your tabular column is as it is. What is your tabular column? Length. Length will be measured from the point of suspension to this. So you start from 5 centimeters. Make the bob oscillate. You know how to calculate the time? This is the starting position. Take it to one end, leave it. Take it to one end and then leave it. This is one. Goes extreme other end. Like this, 20 oscillations. Find the time taken to complete 20 oscillations. Divided by 20, that will give you time period. So, for each length, take the time for 2 trials. Take the average time divided by 20, that gives you the time period. Okay? And how do you calculate? Then, for all these lengths, you finish it up to 85-90 centimeters. In each case, find the time as well as the time period. Then take average L by T square. Average L by T square. Find its average. Once you get that, you have to calculate, estimate the errors using the formula. What is the formula? The formula is, the standard error is given by mu is equal to summation x square divided by n into minus 1 under square root of 110 minus 1. Summation x square is, as you can see, it is sum of all x square terms. What is x? X is calculated by the formula x is equal to k minus z. Where what is k? you already taken L by T square average. The average value of this L by T square is K. And in each case, you are calculating the time period. So, the time period minus Z will give you the value of X. And you take for any values, errors can be either positive or negative. So, whenever you do any error analysis, what you do is you square it. So that if it is positive, it is going to be positive. Even if there it is negative, it is going to be negative. The square of a negative number is always positive. So what you get is an X squared term. Use this formula and also plot this graph. So using this method, you are calculating the errors, the most probable error, and the other error is the standard error. These two you calculate, then it will give you an estimate of how much error this experiment is going to give when you conduct it at different times. So for all these other calculations, generally the data should be very large. That means you can't just take 3-4 observations, a minimum of 10 observations are needed. So you start from 5, then 10 centimeters, 15, 20. You see if you can finish it up to 100 centimeters. If you feel that you are not able to go beyond 200, what you can do is at 0 to 5 you can even reduce further, 3 centimeters, 6 centimeters. So the more the number of observations, the better the result is going to be. Thank you girls.